Yes, welcome to Success Online class. And today we have a question. X raised to the power of x equals 16. We're asked to find x. So we'll be looking at this question straight away. X raised to the power of x equals 16. We're asked to find x. Now, looking at this question, it might look simple, but it's not simple. Someone might think, oh, 16, what comes to mind? 4, right? And you say 4 square. Yes, we know that 4 square means 4 multiplied by 4 equals 16. But is this correct? No. Why is this not correct? Because 4 square means that the base and the power are not the same. Because in this question, x raised to the power of x here is the base, and x is also the power. Meaning that whatever is the base must also be the same number as the power. But looking at this, 4 square means that 4 is the base, 2 is the power. Which makes this what? Wrong. Some might also think, oh, let's try 4 raised to the power of 4, since they must be the same number. 4 raised to the power of 4 means 4 in 4 places. 4 times 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256, which is also wrong because x raised to the power of x must give 16, not 256. Now, let me just recall why this first one is wrong. Of course, it gave us 16, but the method to get 16 is wrong because the method said base is 4, power is 2. But the question said base is x, power is also x. Meaning that the base and the power should exactly be the same number. So that's what makes this wrong. So I'm not saying that 4 square is not equal to 16. Yes, 4 square equals 16, but it doesn't obey the question on board. The question on board says the base and the power must have the same number. So you see that this is also wrong. So what then do we do? You might come in again and say, let us try 2, right? You say 2 raised to power 2. Yes, the numbers are the same this time around, but 2 raised to power 2 means 2 times 2, giving you 4, which is also wrong again because your final answer must land you at 16. So what can we do? The only thing we can do here is to introduce what we call the natural logarithm lane. We introduce what we call the natural logarithm. Please follow me carefully. Natural logarithm lane is what we're going to introduce to both sides of the expression. So the question said x raised to power x equals 16. I'm going to introduce natural logarithm to the left-hand side and to the right-hand side. And this will imply that we're now going to have natural logarithm lane x raised to power x equals to natural logarithm lane 16. Natural logarithm lane x raised to power x equals to natural logarithm 16. Now, at this point, we must recall that the natural logarithm of a variable raised to the power of the same variable can be written as a logarithm a. Because natural logarithm is a type of logarithm, and if you remember in your normal logarithm, log 2 raised to the power of 2 is the same thing as 2 log 2, meaning that this power 2 can come to the back. Same rule allows us to say log 5 raised to the power of 3 can be written as 3 log 5. So this rule that applies to normal logarithm also applies to natural logarithm. Why am I saying this? Because we have the natural logarithm x raised to the power of x. I want to use this rule to allow me to move this x up to the back, so that in x raised to the power of x will be x in x. Since in a raised to the power of a is a in a, I can say in x raised to the power of x is x in x. Please, I hope you're following. So let's do that right away. So now we're going to bring this x to the back, and it's going to be x in x equals to n 16. Please keep following. Next thing we're going to do now is we're going to recall again that e raised to power in a is a. Let me show it to you carefully here. E represents the exponential function. Anytime the exponential function is raised to power natural logarithm of any expression, it could be a, it could be 2, it could be 3. E raised to power n 2, the final answer is just 2. E raised to power n 5, the final answer is 5. So E raised to power n x is what? X. Just like we see 2 here, we'll put 2 here. We see 5 here, we'll put 5 here. And we see x here, we'll put x here. So it means that anywhere I see x, I can replace with e raised to power n x. Now, do we have x anywhere? Yes. We have x here. I want to replace this x with e raised to power n x, because from what I just showed you here, it allows me to replace x with what? E raised to power n x. So this x is replaced with e raised to power n x, but don't forget that we have another n x beside x before. This n x is still here, equals to ln 16. Please follow me carefully. The next thing we're going to do now is we're going to say, bring this in x to this side and bring this e raised by x to this side. Mind you, this is not any mathematical, but I just want to mention this first before this, and there's a reason I'll tell you why. So we're going to have in x. So this in x mentioned first before e raised to power n x. Please, I repeat again. There's no mathematical reason. It's just to mention this first before this. And then we're going to say equals to ln 16. Now follow me carefully. I haven't gotten to this stage. The next thing we're going to remember is the Lambert's W function. The Lambert's W function has a rule. According to the Lambert's W function, the Lambert's W function tells us that anytime we have a Lambert with a product of alpha exponential raised to power alpha, our final answer is alpha. If we have a Lambert's W function, another example. So if alpha was to be 10 exponential raised to power of 10, what will be our final answer? 10. So the key here is this. Anytime you cite a Lambert's function and you have an exponential function, the coefficient of the exponential function and the power of the exponential function, if they are the same, the final answer is those two numbers that are the same, alpha. So cite a Lambert's function, cite an exponential function, and check the coefficient and the power. Are they the same? Yes. 10. But in our main question, so you'll be asking me now, in our main question, there's no Lambert's function. And that's where you come. You're going to introduce Lambert's function to both sides of the equation. Do not forget, when we started the question, there was no natural logarithm. We introduced natural logarithm to both sides of the what? Equation. If you're watching this and you're a bit lost, is normal. What I'll do is that when I'm done solving, I'll take it back again to make you understand. Now let's keep going. So we're going to say, introduce Lambert's function to both sides of the expression, of the equation. So introducing Lambert's, we're going to have W ln x, let's put this ln x in bracket, e raised to power ln x. There's reason why I'm bracketing it, so I'll remind you of something, equals to W ln 16. Now do not forget what I told you about Lambert's function. Anytime you have a Lambert's function and you have an exponential, check the coefficient of the exponential and check the power of the exponential. Are they the same? If they are the same, then your final answer is this 2, alpha. Check the Lambert's function, check the coefficient and the power. If they are the same, your final answer is 10. Now check Lambert's function. This is our main question. This is the exponential. Are these two the same? Yes, in x, in x. So my final answer is in x on the left hand side. So we say in x equals to Lambert's W ln 16. Please keep following. Next thing we need to do, don't forget we're looking for x. We've not gotten x yet. We're going to make x subject of the formula. In order to make x subject of formula, this ln must then move to this side. And anytime this ln changes position from one side of an equation to another, it automatically changes to exponential e. So if you're wondering what will happen to this ln that's changed to exponential on the right hand side, on the left hand side is ln. Once it moves to the other side of the equation, it turns to exponential. So that's exponential because the anti-logarithm of this is exponential. So that will be exponential of whatever we have in the right hand side before, which is Lambert's lane 16. So we're very, very close already. Next thing we need to do now is to find the Lambert's function of natural logarithm of 16. And this is where most students find it very difficult. Many of my mathematics personal mentees that I teach always ask me, how can they use their calculator, their normal school scientific calculator, to solve for Lambert? And one thing you need to know is that your normal school scientific calculator, which is your Casio 99FX, cannot process your Lambert function. So you need a higher calculator, a programming calculator, or you need to determine Lambert's function graphically. In the next video I will do after now, I will do a video on how to understand the Lambert's function and how to use them. But let's keep going. So we need to find Lambert's natural logarithm of 16. The Lambert's natural logarithm of 16 has been computed already and known to be 1.009253708. So this Lambert's natural logarithm of 16 is 1.009253708. So this therefore means that x equals to exponential raised to power 1.009253708. We're very close to x. Now it's time to find x. At this point, you can use your normal calculator. You just go to your calculator and press exponential and input this value. And you see that you arrive at 2.743552759. This is the value of x. And we're not just going to give you the value of x, we're going to test it in the question. If that value of x is correct, the question said x raised by x will give you 16, meaning that if you put in 2.743552759 and raise it to the power of 2.743552759 and you punch an equal to in your calculator, you're going to have 15.9 blah blah blah. You have other numbers there, which when you approximate, of course everybody knows that when you approximate 15.999, you're going to have what? 16, which therefore means that our answer is correct. Now I promised you something before I go. I said I was going to explain it again because it's normal that a student might not have gotten this once. So I'll quickly explain it again so that you can understand. But before I do that, I'll also give you a classwork which I'd like you to tell me the answer in the comment section. Take this classwork, solve, and tell me your answer in the comment section. I have a gift for the first student to get this answer. K raised to the power of k equals to 10. Find k. Find k. Classwork. K raised to the power of k equals to 10. Find k. So go ahead and do that while I explain this again. Oh, sorry, don't do that yet. Follow my explanation so that later on you can do that and drop your answer in the comment section. Please do not forget to hit the subscribe button if you are following this class. Hit the subscribe button so that you can learn more in this channel. Now let's go again. So this time around will be faster because our solution is already on the board. So the question said x raised by x equals to 16. What we need to do is to find the natural logarithm of both sides. X raised by x equals 16. So find natural logarithm of both sides in x raised by x equals to n 16. After finding natural logarithm of both sides, you say recall that ln a raised by a equals to a in a. So ln x raised by x equals to x in x equals to ln 16. We then say recall that e raised to power in a equals to a. E raised to power in a equals to a. Meaning that e raised to power in x equals to what? X. Anytime you have e and you have in, whatever number is there is the final answer on the right hand side. Why did we bring this up? Because I needed to change this x to e raised to power in x. I needed to replace x with e raised to power in x. Why did I need e in my solving? Because in the Lambert's function, by the time I get to this Lambert's function, if I don't have e, I cannot use this Lambert's expression. Because Lambert's expression expects me to have E here so that I can take advantage of this rule that says Lambert's W alpha E raised by alpha equals to alpha. So I need to find a way to introduce E exponential function into my expression. So that's what I did by replacing this X with E. So X is same thing as E raised to power in X. So if you see here from X, I've changed it to E raised to power in X times in X equals to in 16. So carrying it from this side, what I just did is to mention in X first and E raised by in X. And there was a reason in X first and E raised by in S. Because in the Lambert's expression, the coefficient of E should come first before E. That's why I moved in X to this side and E raised by in X to this side. So nothing serious about that. I now reminded you of the Lambert's W function that says anytime you have Lambert's W alpha E raised by alpha, the answer is alpha. Lambert's 10 E raised by 10, the answer is 10. So Lambert, so I applied, and in this part of the question, there's no Lambert so far. We don't have Lambert yet. So what we'll do is we'll apply Lambert to both sides of the equation, apply Lambert to this side, and apply Lambert to this side, so that we're going to have what? Lambert's W function in X, E raised by X, E raised by in X, equals to Lambert's W function in 16. Haven't done that, you now find out that this left-hand side of the equation what obeys the Lambert's W equation that says anytime you have a Lambert's W function and you have an exponential and the coefficient and the power are the same, it means that your answer on the left hand side is just in X. So everything here can be replaced with just lane X. So we now say lane X equals to Lambert's W lane 16. And what we just need to do now is to make X subject to the formula. How do we make X to the formula from here? Bring lane to this side. When lane moves to this side, it becomes exponential. So the lane that comes to this side comes exponential and carries everything on the right hand side. So you see lane W in 16. So this is where the problem now starts. Most students will be stuck here because they'll be looking for this symbol in their calculator and they will not get it. Because it's not your normal calculator. You need a programming calculator to get it. So, but you're lucky that in this class, I've been able to find the value of Lambert's lane 16, which gave us 1.009253708. So that by the time we now say X equals to exponential of 1.009253708, we're going to find out that the value of X is 2.743552759. And when you come and test that value of X in the main question, because the question says X raised by X should give you 16. So if you say 2.743552759 raised to power 2.743552759, you can punch this in your calculator and confirm. You're going to have 15.9 and some other numbers. So it's like if you approximate, obviously, you're going to have what? 16. So thank you for watching. And then I expect you to try and attempt this and drop your answer in the comment section. Thank you very much. Don't forget to subscribe before you go. See you in the next video. Thank you.